Hello, mentors. Let's talk about meeting 5, part 1, and then new stories, which is item number 3 in the activities. Remember that up to this point, students use this rule, I'm happy if at least one neighbor is like me. So they just care about having at least one neighbor like them, each shape, and then they play it in just one-dimensional settings. What will happen now is that we'll play in a two-dimensional setting, but it's very small. And that guarantees that you have more potential neighbors, right? So up to 5 neighbors. For example, this parrot here will have 1, 2, 3, 4, and even could have a fifth neighbor if the parrot moved here. So that's the first thing. We'll play in 2D setting, baby version, very small. And then what's more important, maybe it's we'll introduce a new rule to attract different neighbors. So the new rule is the following. I am happy if at least one of my neighbors is like me, and at least one of my neighbors is not like me. So in particular, I must have at least 2 neighbors. We'll theme this, giving voice to students in many different ways. For example, it could be cats versus dogs, or elves and dwarves, gods and heroes, just creative things. And in coaching, you can develop a few new, or use past meetings where you know your students' interest to come up with really catchy themes in which they could play. So it's just for engaging to make it more fun and more relatable to the students. So that would be the story, a few conflicts between the fictional groups. Let's see how this looks. So in this setting, let's check who's happy and who's unhappy. For example, this pirate, it has one of each, so that's good. One that's like him, or like her, one that's not like her. How about this mermaid? It's good. Neighbor that's similar, neighbor that's not. This pirate here, it's okay. So thus far, looking good. Same for this, here and here. This mermaid here has the pirate and the mermaid. And then we run into this pirate. So we have a problem because this pirate doesn't have another pirate as a neighbor. So this in the game, this pirate would have to move to another place and see if now the problems are solved. So here was easy. This pirate move here, and then it's fine. Notice that in this game, whenever you move an unhappy creature to another place, you cannot create more unhappiness because you're not gonna destroy these other happiness conditions for all these. For example, this mermaid already has a happy place because it has a pirate neighbor and a mermaid neighbor. So even when I move this parrot, this is not going to change. This mermaid cannot be unhappy. Later in different games, when we play the hexagons, that's not necessarily the case. So it's more important, it's more difficult. Let's see what you could also do. So let's take a look at configuration that doesn't look too good. And that's kind of the idea that if your students say start with this, so you could hint them, let's start with some very separated things to see who's happy and who's unhappy. Something like this, for example. Right now, unhappy, unhappy. This is happy, and this is happy. Unhappy, unhappy. This is unhappy, and this is happy. So we have just a few happy creatures kind of in the middle that have interaction with other types of creatures. So then you could start moving things and seeing what happens. Let's say we move this here and here. And maybe we move this here and we move this here. This would be happy. Same for this, same for this, same for this. This would be happy. This would be happy. This would be happy, and this would be happy. So it's not hard to get happy creatures. So this game shouldn't involve too many computations or complicated, calculations or so. But it's more the concept to check that everybody's happy at the end. And notice that this rule from separation, right? Because we started very separated. it creates actually mixing, right? So that's the new concept that you can do in this activity. If you have time, then you could do it more in a mathematical investigation, more general, but you don't need to do this. So these would be the questions. What are some configurations in which all shapes are happy? List some of them. That's going to be pretty easy from the game they played. And then find configurations, if possible, in which shapes are happy for a 5 and 3 configuration, which would be something like this. What if I have less of these then? Maybe I can put them somehow in the middle. That can guarantee a lot of happiness, right? So these are connected, so it's gonna work well. So all the blue would be happy because they have another blue and another pink. And then let's just check that all these pink that are also connected have blues around. And that's gonna be the case. So this would be one such example. Anyway, that's the video and hope you really enjoyed this game. See you in the next one. Bye.